Solar Co-Fusion Systems Incorporated presents OASIIS, the Oceanic Atmospheric Solar Insulated Encapsulation System. This animated depiction introduces a unique, environmentally safe technology that addresses the unremitting pressures upon our environment. This system, floating in seawater, will provide a platform where large-scale distillation, electrical generation, and fertilizer production can be accomplished. OASIIS solves the three major problems associated with producing industrial quantities of electricity from solar energy. These are a vast, energy-absorbing surface area, an efficient and inexpensive method of storing energy, and a means to convert that stored energy to useful purposes. OASIIS will supplement and eventually replace current hydrocarbon, hydroelectric, and nuclear electricity production with an innovative heat engine that is both environmentally sound and economically viable. Part 1. Assembly. OASIIS is assembled from insulated, watertight sections that connect together. The interlocking sections are connected with fasteners that provide a watertight seal and also act as shock absorbers from waves that may collide with the system. OASIIS floats in a body of water and is secured by mooring cables. Floating dock modules feature vertical ballast tanks, which, by means of compressed air, always maintain an optimum elevation above sea level. OASIIS may be configured in three ways, with options for electrical generation, water distillation, and/or hydrogen production. Part 2. Energy collection. Solar energy is stored very efficiently in a large volume of water contained by the system. Sunlight is converted to heat energy and stored in water during the summer months in quantities sufficient to persist through the winter season. Fusion energy from the sun enters through thousands of transparent barriers floating on the surface of the system. These are of two kinds, domed and flat. Domed transparent barriers are used in the vapor-producing portion of the system. The flat barriers of OASIIS transfer heat at very high temperatures without producing vapor, whereas the transparent domes are designed to confine the vapor produced as the water in the energy conversion chamber is heated. Part 3. Distillation. The heat exchangers facilitate condensation. Cool water circulates through the heat exchangers in a continuous loop. The warm vapor produced is attracted by the cool heat exchangers, where it condenses into distilled water, transferring its heat, and then drips into the channel beneath. From there, the distilled water is routed through pipes and eventually to reservoirs within the system. From these reservoirs, a very large conduit, or pipe, follows the contour of the sea floor to a reservoir near shore, where the distilled water is pumped onto land for industrial, agricultural, residential, and recreational use. The heat that transfers from the vapor when condensation occurs is exchanged in the heat storage chamber. From there, the fluid circulates through another heat exchanger, giving up its heat, cooling to a point where condensation of the vapor continues to take place. Producing distilled water is the initial use of the solar energy that enters the system. Part 4. Energy production. The transparent barriers are arrayed in clusters of 16, each cluster serviced by one pump house. Each pump house is equipped with 16 circulating pumps, one for each dome, and associated heat exchangers. The non-vapor producing configuration of OASIIS transfers heat from the energy conversion chamber to the heat storage chamber, without vaporization or condensation. This allows much higher temperatures and greater amounts of energy to be transferred and stored. The water enclosed by the energy conversion chamber has 3 distinct zones. The lower convective zone, where the heat exchangers are located, contains concentrated brine, hence low heat capacity. Salinity decreases progressively with elevation through the non-convective zone. The uppermost zone is water of very low salinity, thus greater heat capacity. When the temperature in the heat storage chamber reaches 95 degrees Fahrenheit, 34 degrees Celsius, the thermal energy conversion, or TEC system, can be engaged. Part 5. Electricity Production Cycle. This unique TEC system features a double closed-loop method and apparatus. It is here that volatile, low-temperature working fluid is boiled to vapor, powering turbines, and by means of flywheels, reduction gears, alternators, or generators, produce electricity. The turbines operate at 150 pounds per square inch, with a vapor temperature of less than 90 degrees Fahrenheit, 32 degrees Celsius. The vapor is condensed upon heat exchangers inside of the sealed condensation chamber. This is the second time the same solar energy is used. As the circulating fluid is warmed, a portion of it is directed through another heat exchanger located in the heat storage chamber, which attains a temperature between 130 and 160 degrees Fahrenheit, 54 and 70 degrees Celsius, where sufficient heat is added to the circulating fluid to boil the working fluid. This is the third time the same solar energy is used. After boiling the working fluid, the circulating heat exchange liquid passes into an ambient water heat exchanger, which is constantly bathed in cold water to remove the heat of work. This water will be pumped past an anti-fouling device to sterilize the larvae of sea creatures that might otherwise foul the external heat exchangers. Continuing a closed loop, it is pumped to the sealed condensation chamber, where it is reheated by condensation of the working fluid. Shown circulating here is the continuous closed loop of the heat exchange fluid. When the vapor is condensed into liquid, it drips into the lower part of the sealed condensation chamber. When sufficient working fluid has accumulated, a high-pressure pump is engaged, forcing the liquid back into the boiler where the cycle continues. 20% of the electricity produced powers the entire system, including all residential and manufacturing components. 80% of the electricity is delivered to shore through cables within the distilled water conduit. Solar energy that would normally be absorbed near the sea surface, then dispersed by currents, tides, and evaporation, is captured and stored by OASIIS. This unique adaptation of a Rankine heat engine makes OASIIS more economical than current methods of electricity production in every way. Part 6. Hydrogen Production. The hydrogen production facility is comprised of many cylindrical tubes, mostly underwater, within the energy conversion chamber. The tubes are divided by a perforated septum that prevents the mixing of hydrogen with oxygen while allowing electricity to flow through the brine within the tube. These gases rise, without mixing, into separate pipes and are routed to the chemical production facility, where they are used in the manufacture of several products. These are located on the shoreward side, along with the vehicle garages, car parks, and necessary warehouses. Seagoing vessels may be accommodated to take on the products of the system and deliver necessary commodities for maintenance personnel, as well as those visiting the motels, restaurants, and other facilities in the recreation area. Part 7. Safety. OASIS is designed to withstand the storms that would normally be expected out at sea. In regions where high seas or violent winds are a regular occurrence, the system is built with a rigid, open structure between the perimeter seawall and the main system. The open area between the seawall and the system provides an area for very large waves rolling over the perimeter to flow back into the ocean without inundating the working portion of OASIS. Hundreds of electrically insulated mooring cables connected to cement anchors drilled into the sea floor allow OASIS to move in response to changes of tides, currents, and surface conditions. This also provides the means by which OASIS is electrically grounded. Part 8. Delivery of resources. The conduits from each of the distilled water reservoirs flow into the large conduit from the system to the sea floor and along the sea floor to a reservoir near shore. Electricity provided by OASIS is delivered through cables within the distilled water conduit. The OASIS system is a remarkable and innovative solution to the unremitting pressures upon our environment. OASIS solves the three major problems associated with producing industrial quantities of electricity from solar energy. Though the potential for producing vast commercial amounts of distilled water is compelling, the greatest value of OASIS is its ability to generate tremendous quantities of electricity. In short, OASIS provides an environmentally sound and economically feasible alternative to fossil fuels and will eventually replace current hydrocarbon, hydroelectric, and nuclear electricity production. OASIS.